So, guys, first of all, good evening. Let us wait for another 5 more minutes so that other participants could join this session. So, shortly we'll start the session at 6:05. Yeah, hello all. Once again, very good evening. I welcome all the participants for this IBM Hack Challenge 2022. So before starting the session itself, we got some queries on Q&A and all. So most of the questions like when you will get the exercise recording. So we will make it available as soon as possible. So kindly give us some time. So what are the topics we will learn today? Yeah, we are going to start it. So I will explain the agendas and all. Yeah, okay, guys. Yeah, on previous days you have learned many things. Once again. On previous sessions, you have learned uh, many concepts which is based on deep learning, machine learning, and all. So I think you are clear with the CNN theoretical part as well as an practical part. Then last session you have learned the regression, right? So you have learned practical implementation, sorry, theoretical as well as practical implementation. Yeah, if you have any doubt regarding the course content and all, kindly reach us on Telegram. We have Telegram group, right? So kindly reach us there. So mentors are available there. They will reply your queries and all. So today on this session, if you have any doubts, so kindly ask the queries based on today's session. So I will help you for that. Yeah. Okay, guys. So previously you have learned regression, then like practical, which means linear regression. You have learned a theoretical way as well as in a practical way. Then you have learned CNN and how to deploy CNN model on IBM model. You have learned. So today, what's the agenda is? Today we will try to learn two things. On supervised learning, we are going to learn classification types of problem. Then when it comes to unsupervised learning, on unsupervised learning, we are going to learn k-means types of algorithms. So first of all, what is classification? I'm asking a question that what is classification? If, kindly give your answers on Q&A section. So based on your understanding, kindly give your answer. If it is wrong, not a problem. So kindly tell guys, what is a classification? Previously, you have dealt with regression, right? So what is classification? Can anyone? Yeah, segregation of data based on their type. Yeah, discrete. Yeah, okay, guys. I got some of the good answers. So first of all, before understanding the classification, you have to understand the regression. You should understand where regression is used, where classification is used. So for example, this machine learning concept itself, we will work on the structured data, right? So when it comes to unstructured data, we will go for deep learning concepts. So on structured data, what and all we can do, how the data might be. So the data might be in the form of you could have an dependent variable as well as independent variable. In some case, you will have only independent variable. You won't have the dependent variable. But anyway, the data will be in the form of some like Excel format. Some rows and columns will be there. Those sort of data we are calling it an structured data. So on that, the target variable will be there. Like you can term it as output or a target variable or a dependent variable like that. The tech name, many things are there. So you can term it with anything like that, whatever you want. So like a target variable or output, if that values, which is in the form of continuous values means, you have to go with the regression model. So if the values is based on discrete or some true or false type of things means, you have to come up with the classification types of algorithms. So for example, when it comes to regression, if you want to think you are working for an organization, and if you want to predict your salary means, we could train the model based on some input data, right? So the data might be like your performance, then your name, those sort of things, age, experience, those sort of things will be there. So based on the data, we are going to predict your salary. So think your salary, which means on an organization, if for example 500 employees are available on an organization, means they won't give like 20K for all the employees, and they won't give 50K for all the employees. So how they are doing based on the employee performance, they will get some different salary packages. So based on the employees, which means based on their employee performance, the employees will get different salary packages. So how there is no like end value for the salary, right? So some might get 10K per month, some might get 1.5 lakh per month. So like that, some n number of continuous values is there. There is no limit for this salary. So in this case, you have to use regression types of problem. In this case, you have to use regression types of problem. So when it comes to classification, on classification you can use like so for example, if for example I'm telling, if a person has a diabetic, so what the output might be. So he's going for a diabetic test, so what the output might be, like positive or negative, right? So whether he has diabetic or he are not having diabetic, so this might be the output. So here some categories there, only two categories there. So, or for example, true or false of problems, sorry, true or false of problems. So for that problems and all, you can use this classification. Um the values, which means the output values might be in a categorical form or as well as a discrete form. So in this classification today, what we are going to see is we are going to understand about the logistic regression. Yeah, before that, guys, if you have any doubt, you can ask on Q&A session. So, sorry, section. So what I prefer is like last 15 minutes, I will completely take over this Q&A. So on the time, I will answer all your queries. So in between, as well as taking class session, then as well as like answering the queries, it is not possible for me. So I request all the participants, if you have any doubt, kindly hold it with you. So at last 15 minutes, I will completely engage with this Q&A section. So you can ask your doubts and I will give answer for your queries. So see guys, on classification, see, don't confuse. Here I have given the name like logistic regression. So this logistic regression is a classification algorithm only. Don't think that, okay, here the regression is there, so it is a regression like that. Don't think in that way. So you have to understand linear regression first of all. So on linear regression, which means the like this session, what you have learned, what will be the actual working on that linear regression. We have to find the best fit line. So for example, we have some x-axis, y-axis, some graph is there. Inside that graph, we could find some data points, which is nothing but an like input data we can assume. So if you use a linear regression means what actually it will do. It will just create an best fit line, straight line. It will create, and it will try to get the best fit line among the data types, which means among the input data. That is called a linear regression. But here logistic regression, here also instead of straight line, we will use S curve. We will use S curve. That is the difference. That is the difference on logistic regression. So I will give like a overview of this logistic regression. And before getting into this logistic regression itself, I will tell you today it is a combination of theoretical session as well as practical session. First of all, we will understand this logistic regression in a theoretical way. Then we will go for the practical. On practical, with the help of Python, we will do some codes. Then again, we will come to the unsupervised learning. On unsupervised learning, we use k-means. First of all, we will start with the theoretical way. Then we will try to implement the code. So now logistic regression. So what is actually logistic regression? Can anyone? On Q&A, can anyone answer that what is logistic regression? Based on your understanding. If your answer is wrong, not a problem. Based on your understanding, kindly give the yeah, more than 200 participants are available here, so I want this session to be an interactive session. Yeah, estimate the probability of event occurring. Yeah, super, correct. So see here, guys, in logistic regression, the logistic regression is one of the most popular machine learning algorithm, which comes under the supervised learning technique. So like when it comes to machine learning and supervised learning, we have n number of algorithms. But in our case, we will use the popular algorithms only. So logistic regression is one of the popular algorithm. And when you can use logistic regression in the sense, you might have yes or no type of questions or a binary type of output will be there now. So on the time you can use this logistic regression. Whenever the output is in the discrete form, on the time also, which means like 3 categories were there on output session means, you can use this logistic regression. but on that time this logistic regression might not give a better accuracy. But when you pass or when you train these algorithms for the binary output data, on the time it will be helpful. Logistic regression will be working fine. So what this logistic regression actually does is, so here the output will be in the range of 0 to 1. So whatever the input data you are passing, the output data, which means the whatever output we are getting, the output values will be in the form of 0 to 1. It is nothing but an probability value. So if you want to understand this logistic regression, you have to be familiar with the linear regression. It isn't like an you can tell it as an somewhat most of the similarities this logistic regression have from the linear regression. So as I said previously, on linear regression, you will have a you should find a best fit line. It will be in a straight line. But when it comes to logistic regression, you have to find the S-bend curve. That's it. So then it is an significant machine learning algorithm. Why? Because only this algorithms will give the output in the form of probability values. Other algorithms, it will give the actual value, but this logistic regression, it will give the algorithms in the form of like uh, probability values. So without making any delay, let's understand with one example. So see here, guys. Here I have given a two graph. So in this graph, what I have shown is like here you could find salary, then experience. Here you could find salary and experience, and here I have made a scatter plot. So on scatter plot, like here you could find some data points, right? Here you could find some data points. So in my case, if I want to predict the salary means, with the help of linear regression, what I'm doing, I'm trying to find this. Here you could find one black line, right? So here I'm trying to find the best fit line. So after finding the best fit line, I'm with the help of losses and all, calculating the errors and all, I'm finding the best fit line. This is like linear regression. See here, this is a logistic regression approach. So here in this approach, we are having age as well as purchase. So based on the age, we are making whether this age category customer is purchasing a similar product. I'm not mentioning a product. So just think it. So whether they are buying this product or not. So here, what the case might be two, right? So whether the person they are buying or a customer, whether they are buying the product or not. So for buying means we can make it as one. If they are not buying means we are considering it as zero. So if you scatter the data types means, which means if you make the scatter plot on the data means, so it will be in the form of this, like you could find an x-axis and y-axis. Here you could find red color plus marks, right? So these marks are called like data. These are the data when we are plotting. So here, in this case, if you pass the straight line, which means in this case, if you use a linear regression means, think how it could predict. Mostly misclassification will happen. So mostly misclassification will happen. So see here, like data points is not very fine, right? So in our case, the line should be like this. Line should be horizontally like this. If we have some case means, which means like if the age, let's take like earphone and all, let's assume the product is earphone. So who might buy the best earphones? Sorry, who might buy the earphones and all? Like teenagers, they are willing to buy the earphones, right? But if you ask to your grandma or grandpa, they won't like the earphones and all. So based on the age category means like teenagers from like till 30 age, they might like the earphones and all. But after that, they might get bored or some health issues will happen to them. So they won't consider this earphones and all. Yeah, give me a minute, guys. Yeah. So in this case, what we can do here, we want to segregate these things. The one also we have to segregate, this zeros also we have to segregate. So what we can do for this, we are using the logistic regression approach. So this is the actual thing, which means it is not a perfect S-bend curve. Here you have a graph, right? Like you can go like this, then after that you can go like this. So here assume till this point it is like a teenager. This point it is like an old person. So zeros they're buying the product means. So the teenagers, which means like age from 0, which means like first year to age of 1 to age of 30, they're buying earphones. And some of the 30, which means like 25 plus to 30, those persons they are not buying. So here you could find some plus points. So after that, the more than 40 years, so they are not willing to buy. So here you could find other points like that. Assume this, it is an example. So here what we are going to use is we are using a sigmoid function. So previously I told you that S-bend curve, right? So that S-bend curve is nothing but a sigmoid function. So the formula for the sigmoid function is P equal to 1 divided by 1 plus e power of minus y. So guys, when it comes to machine learning, it's completely based on the statistical approach only. So you will use the the algorithms. All the algorithms will be built based on the formulas only. So if you want, you can remember these formulas, but just what I request you to you is just understand the concept, like how linear regression is working, those sort of things. Just to understand it. Why? Because on practical implementation, we no need to write these formulas and all. We no need to write these formulas with the help of Python code. We have some packages like sklearn. We have some package we are having inside that itself, like pre-trained algorithms is saved. Inside that algorithms are already saved. What we are doing is we are just importing from the sklearn, then we will implement it. But anyhow, if you are doing some work, means we have to understand the backend, right? That how it is working, those sort of things we have to understand, right? So we are going through it. See here, it is the actual thing. Y equal to b naught plus b1 x. So in other case, y equal to mx plus c. So instead of b, if you keep m, means you could understand easily. So this is the actual formula of straight line linear regression formula. But when it comes to if you compare this linear regression with logistic regression, means this is the formula. Linear regression, b naught plus b1 of into x is equal to ln of p divided by 1 minus p. So here p represents the sigmoid function. This is the actual formula of logistic regression. See guys, this is the actual image. So this is the actual image. If you perform this task, which means if you perform or if you try to give a solution for this use case, means here if you are using linear regression, means on the time you can't get the better accuracy. The line will be like this, so you can't get better accuracy. Instead of this, if you work on with the logistic regression, means here the curve will be in the form of S-bend. This is the actual logistic regression curve, sigmoid function. It is called a sigmoid function. On neural network also, you could learn this activations and all. So the shape of, just to think, the shape of like sigmoid function, it will be in the form of S curve. We will call it as like S curve or S-bend curve, like that we will term it. So this is the actual thing. So here what all happening is, here you are having most of the output it will cover, and it will gradually rises, and from here most of the output is will cover. So the comparison of this type of model and this type of model is, if you use this type, means here the error will be very less. So why we are using machine learning and these algorithms and all? We have n number of algorithms, right? We are performing each and every algorithm. So why we are using that? We have to overcome the error, and we have to make our statistical model accuracy to be very high. So this accuracy as well as error has an interconnection. Whenever the accuracy is increasing, automatically the error will be decreasing. So whenever the accuracy is decreasing, automatically the error will be increasing. See, just this thing you have to keep on your mind. We have to reduce the error. That's it. So if we follow the logistic regression approach for the this type of binary classification problems, your error will be very less, so that your model will get better accuracy. Yeah guys, I could find many queries on Q&A. I request all to hold the queries. Why? Because at last 15 minutes I will ask, we will have a Q&A session. So on the time you can ask your queries, so I will answer your queries. Yeah, so I hope guys, I need a quick confirmation on Q&A. that I hope this everyone understood this logistic regression, right? So what is the difference between linear regression and logistic regression, right? In simple words, logistic regression has the logistic function called sigmoid, this S-bend curve. Why we are using this approach? To reduce the error, of our model. That's it. So can I get a quick confirmation on this chat, which means on this Q&A? That, yeah, okay, thank you. So now we will go to the practical implementation of this logistic regression. So in today's practical implementation, we are not going to use IBM, which means inside IBM you have Jupyter notebook, right? We are not going to use that notebook. Today, what we are going to use is, today we are going to use Google Colab. So I will show you that how to open Google Colab and how to use Google Colab and all. So kindly give me a minute. Let me share my browser screen. Yeah, guys, I hope everyone could see my browser, right? Yeah, logistic regression works for classification data. Yeah, how to give attendance? See, whenever you are joining, we are marking the attendance, so don't worry of it. Yeah, guys, can I get a quick confirmation that whether my browser is visible to you or not? Yeah, okay. Yeah, first of all, guys, if you want to continue with me, like if you want to work on simultaneously, you can open a browser and here you can just type Google Colab, just type Google Colab and press enter. So at first link, you could find the welcome to Google, which means welcome to collaborate, like that you could find. So just click on it. So after clicking here, you could find some notebooks and all, which means here, these notebooks I have previously created, and these are my existing notebook. So in your case, you could not find anything. You could find only this welcome to collaborate. So from here, what we have to do is you have to click on this new notebook. You have to click on new notebook. At right side bottom, you could find a new notebook option. So you have to click on that new notebook. So once after clicking on this new notebook, this is the actual. Yeah. So this is the actual interface of this Google Colab. So here what you can see is you could find like untitled 0, like. So this is the name of your like Jupyter notebook. So what you can do is just double click on it, and whatever name you want, you can give for it. So in my case, I'm just giving logistic regression in a short form. I'm giving it. So then just press enter. So the name will be saved. After that, here you could find files, right? So here, whatever, if you want to like, once again, guys, if you want to download or if you want to save, you can use this file. And at right side, you could find the connect option. So before running this code, we have to connect to the kernel, which means like for this, we have a server. When you are using your local Jupyter notebook, which means with the help of Anaconda Navigator, you can download the Jupyter notebook. So from that, if you are using this, there you should connect with the kernel. But here we have to connect with the server. Why? Because this Google Collaboratory is an virtual. See, first of all, let me connect and let me explain you. Just to click on connect. So it will take like 20 to 30 seconds. It will take. Yeah, see here, guys. Here you could find RAM and disk, right? Like for RAM, it shows like 12.68 GB, and from that, like 0.81 GB is used. And when it comes to an disk space, means it's showing at 107 GB. So this RAM and disk is not like my laptop configuration. This is not my laptop configuration. Why? Because if you are executing your code on your local system, which means your laptop means, with the help of a local Jupyter notebook means, there whatever computation you are doing, those computation memory, it will consume the RAM, which means your system RAM. But here this is an virtual type of environment, right? So here, if you are using the your code means, it won't affect your system RAM. It won't affect your system RAM. Why? Because virtually they have given like 12 RAM they have given. In Google Colab itself, virtually they have given 12 RAM. So we can use this 12 RAM for our further computation and all. So here, first of all, if you want to do any code means, first of all, what we have to do? We have to import the necessary libraries, right? So here, what I'm move your cursor like top or bottom. So if you are moving the cursor to top means, here you could find like some text you could find. So here I am, in my case, I'm just clicking on this text. Then here what I'm doing is I'm just giving a heading like importing the required libraries. Importing required libraries, and here yeah, I hope everyone worked on the linear regression, right? So I hope everyone already knows the pandas, numpy, sklearn, those things and all. So in my case, what I'm doing is I want to import those packages. So I'm importing import pandas spd. Then I have to import a numpy as np. So where this pandas and numpy is useful is if you want to like manipulate the data which you are in the form of CSV or whatever data you are getting. If you want to manipulate that data, manipulation in the sense control the data. For that, this pandas and numpy will be helpful. The next thing what we are going to do is we are going to import sklearn. So from sklearn.model selection. So from sklearn.model selection, import train test script. So import train test script. So when I'm when I'm splitting the training and testing data, on the time I will explain actually what the train test script is doing. So after that, I have to use the logistic regression, right? So where I can have this logistic regression. Previously on slides, I have showed you some formulas. Here, with the help of Python, we no need to write those formulas and all. If we are writing the formulas, we have to give multiple conditions. Then we have to write a huge number of huge lines of code, right? So to overcome that, sklearn module on sklearn itself, we have some algorithms or saved inside the sklearn. So what we are doing is just we are importing from sklearn. So from sklearn.linear model, import logistic regression. So import logistic regression. So after that, I'm just executing it. So see here, in this notebook, all the package, which means all the packages which I have mentioned here, everything is installed. So whenever I want, I can use those things. So in my case, so if you want to perform any logistic means we have to deal with the we have to deal with some we need some data, right? So where we can find the data. So 1 second, guys. I will share one link with you guys. Kindly wait. Yeah, guys, on chat I have shared one link. Uh, Guys, on chat, I have shared link. It is accessible to everyone, right? Can I get a quick confirmation on Q&A? Yeah. So by clicking that link, you could find two different data sets. So today we are going to deal with those two data sets only. So in our case, what data set we are going to deal with is in that, which means in the drive folder, you could find a social underscore network underscore ads.csv. So we are going to use that data only. So in my case here, we want to upload the data. So if we use Google Colab means directly we can connect to our drive also. So in my case, I no need to connect with the drive. So here what I'm doing is I'm just uploading the data. So just to click this icon, guys. If you click that icon means it will be automatically going to your my computer. So from my computer, whatever, which means how you have downloaded that. If you download this data set CSV file means it will be on your download folder, right? So you can redirect to the download folder and you can click that and click on open. Automatically the data set will be uploaded here. Automatically the data set will be uploaded here. So from here, what we can do? Data set is uploaded here. So what we can do? We have imported packages also. We have to read this data, right? We have to read this data and we have to understand that, okay, what are the data available on this data set. So like okay, what happened once again. So here I'm just giving a comment like read the data set I'm giving. Then with the help of pandas. So df equal to, like previously we have defined pandas as pd, right? So I am giving pd dot read underscore csv. So inside this, what we have to pass is we have to pass the exact location of this CSV file. So for example, if you go to your like my computer, from that, if you are taking the like C location and that or D location, where on whichever location we are having this data set, we are copying that absolute path, and if you are pasting it and if you are executing it, you will get an error. Why? Because this notebook, it is not working on your local system. Virtually it is working. That's why we have uploaded data set here. So here what we can do is just to place it here, and here you could find an option. So next to that data set, you could find three dots. Just to click on those three dots. Here you could find copy path option will be available. Just to click on copy path, and here just to paste it. So before pasting it, open a single quotes or double quotes and just paste it here. Then run it. So see, it got executed. Instead of this slash content and all, if you use different things, you will get an error. Why? Because for this virtual IDE, here this content, everything will be saved inside this content only. Yeah, you're asking, sir, please share the drive link again. Yeah, okay, guys, give me a minute. I will share it. Guys, again, I have shared the link on the chat. Kindly check it. Yeah, I will share the drive link in Telegram also. So after the session, I will share the drive link on this Telegram. So as of now, multitasking is not possible. So let us work on this actual code. So see here, guys, I have loaded this data set into the variable called df. So now I have to visualize the values. So I have to visualize that what and all available on the this data set I have to visualize. So for that, what I can do in like pandas, we have a like function called head. So here I'm using df.head. Then I'm executing it. So here I could find the first 5 rows. So if we use head means you could find the first 5 rows. It will be visible. If you use df.tail means last 5 rows will be visible to you. Inside the head, if you pass like 10 or 20 means, for example, I'm passing it as 10. So you will get the 10 rows will be available. But for default, you will have a 5 values. For default, you will have 5 values. So after this, what I am doing is I'm trying to make a descriptive statistics. So here what I'm going to do is I'm going to make an descriptive statistics. So just a short form. So we are running out of time. So that's why I'm using like short form things and all. Like to stat like that I have given. So what is actually descriptive statistics? What and all comes in descriptive statistics is you can find the minimum value, like maximum value, then mean, median, standard deviation. Those things and all comes under descriptive statistics. So for each and everything, for mean we are having a formula, for standard deviation we are having a formula. So for each and every category we are having a different formulas. But instead of writing a multiple lines of code, on pandas we have a function called describe. So we have a function called describe. So I'm using df.describe. So I'm using df.describe and I'm executing it. So see here guys, with the help of this describe function we could get everything. Like we could get the standard deviation for user id, for age, then for estimated salary, then this minimum value for each column, then mean for each column, count for each column, like maximum value for each column. Then here you could find like 25%, 55%, and 75%, right? These are nothing but the a quartile. This first quartile, second quartile, third quartile will be there, right? So 25% of the data, then 50% of the data, then 75% of the data. So with the help of describe function, we can get all this value. But see here, guys, in our data set, we are having the column like user ID we are having, then gender we are having, age we are having, estimated salary we are having, and purchased we are having. So in our case, from seeing this data set itself, we have to understand that what we are going to predict. What we are going to predict. So in our case, we are going to predict the purchased column. So purchased column is the target variable, or in other terms, we can tell it purchased column is the dependent variable. Other columns and all independent variable. So other columns and all independent variable. So here this user ID, age, estimation, and purchase, these are in the form of like you can find this in int values, right? But this gender, it is an categorical value, which means it is a string value. It contains string value. When you are using df.describe, we couldn't find that gender column, right? We couldn't find gender column. So what we can do is here you can just type include equal to all. You can use include equal to all and you can execute it. So now gender, which means like a object data type also will be available here. So here what you can see for like string values and all, we can't find mean, standard deviation. But whatever we can find the unique values. We can find the unique values. Then we can find the like a frequency of value frequency. Then we can find the topmost values. Those things we can find, right? So here we are using include equal to all. So next what we can do is we have to find the shape of our. Hey, we're asking that it is streaming on YouTube. No, it is not streaming on YouTube. It is a webinar. So after this session, by within 24 hours, you will get the recorded videos. So now what we are going to do is we are going to find the shape. So how can we find the shape? So before finding, I'm just giving an like a comment I'm giving like finding shape like that I'm giving. So you might have doubt that, okay, why I am writing these commands and all. So here in my case, I am writing the code, right? So whenever I see this code, I can easily understand, okay, I'm using this, like importing the required libraries, then here I'm doing these sort of things and all, I can understand. But if I pass this notebook to some a different person, they are not familiar with the concept means, how they can understand? By seeing this command. Okay, in this, with the help of this code, he is going to find the shape of the data set, like that he could easily understand. That's why I'm using this command line. And I request all the participants, if you're working on your like projects and all on the time, kindly use this command line, so that it will be helpful for your like future. If you're opening the code means on the time, it will be helpful for you to understand in a quicker way. So here, how can I find the shape of the data set? I can use df.shape. I can use df.shape, and I'm just executing it. See here in this data set, which means in the social underscore network underscore ads.csv data set, we are having 400 rows and 5 columns. In that 5 columns, our target variable is purchased column. So here the confidential, right? So they have not given the actual product name. So instead of actual product name, what they have given is, okay, this product is purchased or not. Like that, here they have given this is a binary type of classification problem. So before working on the machine learning algorithms and all, what we have to find, what we have to do, we have to collect the data. Then after that, we have to read the data. Then we have to do some manipulation on the data, which means like data cleaning. Those sort of things we have to done. After that, the data will be ready for the algorithm. Then only we have to move to the algorithm phase. So here on machine learning, you might think that okay, machine learning is someone might think machine learning is easy, machine learning is tough. And when it comes to machine learning, algorithm plays the important role, like that and all. Someone might think, but that is not the actual case. Think, guys, actual machine learning engineer on his time consumption, which means like 100% of time consumption, 70% of time he will spend only on the data cleaning process. So 70% of time he will spend only on a data cleaning process. Then the other 30% only he will look on into like a model building, evaluator model, testing model, those sort of things are all he will do. Why? Because if we have a cleaner data means, if you pass the data to algorithm means, you will get a better accuracy, and you will get a better prediction. So whatever problem you are having, you will have a best solution for that. So in our case, we have to check whether we have null values or not. So how we can check null values? I am using like df, nothing but my data frame, right? So df dot is null. So is null is a function on the pandas dot sum. So see here, guys, I'm executing it. So here as an output, each and every column name is available. After that, here you could find 0, right? So if you find 0 means there is no null values in this data. If you have some values means you have some null values. So with null values, you can't create the machine learning model. If you have null values, then you have to either remove that null values, or you have to pass some values to that null value. So in our case, there is no null value. So we are skipping the step of replacing null values and all. Okay, here also I will just write in command like finding null values. So here I'm just giving a command like finding null values. See, guys, why I'm on each and every line, why I'm writing is, so after the session, I will share this notebook on and the dataset link on the Telegram also. So if you want, if you have any doubt, you can refer that also. So next, guys, see here, guys, here we have like user ID, gender, age, estimated salary, then purchase and all. So in this, for predicting this purchase, this user ID is not required, right? Why? Because user ID is a unique value. For each and every users, there will be a different, which means a unique user ID will be allotted. So for predicting the purchase and all, whether the customer is purchased or not, there is no sense. The user ID doesn't make any sense, right? So we have to remove that user ID. So what we can do? On pandas, we have one of the best function called drop. So with the help of drop function, we will drop this user ID. So here, what command I'm going to give is like dropping unwanted column. I'm giving dropping unwanted column. So here, what I'm making is df dot drop off. So here, what we have to pass? We have to pass this user ID, right? So how you can pass? You have to either you have to define an axis, or you have to give the column or rows word, like a keyword that is called nothing but a parameter. See here, you could find the parameter, right? Like axis, you could find like columns, you could find levels, then in place, those sort of things you could find, right? So here, what I'm doing is I'm just typing columns equal to, here what actually we have to give, we have to give this user id. We want to drop this user id from our data set, so here I'm giving the user id. Then after that, if I execute the cell means, so this user id will be removed, but it won't be updated on this df. It won't be updated on this df. So for updating on the df also, what I can do is I have a parameter called in place. So as default, in place will be on false condition. So what we have to do is you have to change it to true. So in place equal to true. So true is a keyword in Python, which has a special meaning. So I'm just executing it. See, now I'm going to visualize the first 5 rows. So what I'm doing, df dot head, and I'm running it. So see here, now we have gender, age, and estimated salary. Then purchased column. That's it. We are not having the like user ID. We are not having. Why? Because that is not important for us. So see guys, when you are learning linear regression, which means on starting of the supervised learning itself, everyone could know that if you are building a model, which means like if you are building a model with the help of algorithms, algorithm won't accept this categorical data. Algorithm won't accept this categorical, which means like a string data. It won't accept string data. So what I can do, if you want to find the data type means, what we can do is like just type data frame of info, just type it and execute it. So here you could find the data types. So this gender column is in object type. Other columns and all, it is an int. So a machine learning model can accept the input data in the form of int, float and all, but it won't accept this object category. What you have to do is you have to convert this object into int or float. How you can convert? So how you can convert? Here, what I'm going to do is I'm using a technique called feature mapping. So here I'm going to use a technique called feature mapping for this gender column. So you can use feature mapping or you can use label encoding and all. So that is based on your wish. 1 minute. Yeah. So that is based on your wish. So in our case, what I'm going to do is like, first of all, I'm calling the data frame. So df of here, what I have to give? I have to give this gender, right? So in my case, I'm just copying this gender instead of typing. I'm just copying it and I'm just pasting it here. Dot replace. I want to change the value, change the male and female value with zeros and ones. So for that, what I can do, I can replace it. On pandas, we have a function called replace. With the help of replace, we can change the values. So replace. Then I'm giving the parenthesis. So here, what how the data should be is, it should be in the form of like dictionaries. You should find the keys as well as the values. So whenever we are talking about dictionary, we have to open and close this flower bracket, right? So inside the flower bracket, my first value is like male. My first value is like male. Then the replacement values, I'm making it as 1. Then I'm making a comma. Then I'm making it female. Then here I'm making a replacement value as 0. So see guys, that's it guys. Again, I'm telling, if I run this means it will be updated here, but it won't be updated on the entire data set. So what I have to do, I have to use in place equal to true. So in place equal to true I'm using. See guys, it got executed. Now again, I'm going to visualize. So what I'm doing is control V. So see here. See the output of these things. Here you could find 1 and 0, right? Wherever there is a male, it is automatically replaced with 1. So wherever there is a female, it is automatically replaced with 0. So this technique is called a feature mapping. So you can use feature mapping, or you can use like label encoding and all. Yeah, guys, I need a quick confirmation that whether my voice is audible to everyone. Guys, can I get a quick confirmation whether my voice is audible to everyone? Yeah, someone is asking why we are not writing this. What we are not writing? Can I get? No, it is not called one hot encoding. One hot encoding is different. See, for a problem, we can find a solution in n number of ways. So on that n number of ways, this feature mapping is one of the way. That's it. Yeah, guys, as I said previously, as of now, I'm not able to see the queries which you are asking on Q&As. So why we are not writing data frame general.replace? Yeah, thus we can use what we have done also. Like you can initialize the condition, which means like you are passing like df equal to. Okay, wait, I will show that also. Yeah, see guys, this in place is one of the method, and the other method is like this. So other method is like this. Instead of using this in place equal to true, instead of using this parameter in front of the code, you can use df equal to. See, as I said, these are the different techniques. So from the techniques, whichever technique is comfortable for you, you can use that. With the help of machine learning for a problem, we can find solutions in different approaches. From that, you have to select a best approach based on your comfortable. So see here, guys. Here till now we have cleaned the data. After that, what we have to do? We have to split the data, right? So what is the difference between label encoding, feature mapping, one-hot encoding? See, label encoding, feature map, one-hot encoding. Feature mapping and one-hot encoding. Feature mapping means manually we are doing. So here manually we are giving value like 0 and 1, right? That is called feature mapping. Label encoding means it is an automated way. Automated way in the sense label encoding, it is an automated way. Automated way in the sense on sklearn you have a package, just you have to load that package. Then if you pass that means it will automatically convert the categorical values into 0 1 2 3 4, like it will convert based on the alphabetical order. That is called label encoding. When it comes to one hot encoding, whatever category you are having, for example you are having like true or false, means what it does is it makes the categories into a columns, like true as one column, then false as one column. So whenever your value is true means there it will replace with 1, then on other column it will be replaced with 0. So wherever the value is false, for false you will get 1, then on true you will get 0. So this is the actual difference. So see guys, some of the queries I couldn't answer on Q&A. Why? Because if I totally answer Q&A means I can't go with the uh, course content and all. So as I said, last 15 minutes, I will try to answer your all queries. So see guys, after this, what we have to do is, we have to split the data. Why? Because we have to train which means we need like dependent and independent variable, right? Then only we can pass into a machine learning model. So here in our case, these are the columns. These three, which means these three columns are called, these three and this entire values, these are called independent variable. This is an variables. So these are called independent variables. And this one purchase, this is called a dependent variables. Why? Because this column is dependent with these other columns. That's why it is called dependent variable. Or in other words, we can call it as a target variable. So here what I'm going to do is, I'm going to split it with X and Y. So before that, I'm giving a command like splitting data for, I'm just giving like splitting data. So splitting data, then X equal to, so for X equal to, what I'm doing is I'm just dropping this purchase column. So what I can do, df dot. So previously Das has asked one doubt. So now I'm going to use that approach. Df dot drop off. So here what I can do is I'm giving this purchase. I'm going to copy this. Then I'm going to give this. Then after that, what I'm going to do is I'm giving access equal to 1. See guys, previously what we have done, here what we have done, we have not given access and all. Why? Because we have given column. This is one type. This is one type. The other type is instead of column, you can give access equal to 1. You can give access equal to 1 means it represent column. Access equal to 0 means it represent rows. That's it. So after that, what I'm going to do is I'm going y equal to, so here like df of purchase. So on y variable, I want only this value, and on x variable, I want this independent variable values. I want this independent variable values. Now I'm executing it. So for your understanding, I will showcase this. So x dot head, I'm giving. Then just to see here. So can you see here? This purchased column is eliminated here. The purchased column is eliminated here. If I just type like y means, here you could find the y values. Here you could find the y values. So now we have split x and y. After this, what we have to do? We have to further split it, right? Why? Because for testing and training, right? Then only whatever, see directly you have x and y. Directly you pass these two values to your model means you can't check the performance of your model. You can't evaluate your model. If you want to evaluate your model means, if you want to find the accuracy and if you want to evaluate your model means, you have to split the data into test, train and test. So how you can do? Previously I have shown this model selection, right? From model selection you can use train test split. The same thing you have to do here. So here what I'm going to do is I'm just giving like x train comma x test comma then y train comma y test. Y test equal to, like I'm going to give like a train test split. So previously we have imported this. So I'm giving train test split. Then I'm opening and closing the bracket. So see guys, if you are not aware of this x train, x test, if this is confusing for you means like you are giving x train, y train like that and all, if this is confusing for you means what you can do is just to type this train test split, then open and close the parenthesis, place your cursor inside the parenthesis and make a click, then hold shift and press tab. Hold shift and press tab. 1 minute. So here you could find a description of that. So if you just scroll down means here they have given the example also. Here they have given the example also. So you can just copy this and you can paste it here. Just you can copy this and you can paste it here. So here on train test split, what I have to pass? I have to pass my independent variable as well as dependent variable. So I am passing x and y. After that, what I am doing is I am defining my test size. I am defining my test size. So test underscore like size equal to 0.3. So 0.3 is nothing but 30%. So for example, if I have 100 data means like 70% of data will be for training and 30% of data will be for testing. So you can train the model with 70 data and after that for checking your model, you can test the model with the other 30 data. Then here what I'm going to do is I'm going to give a random state. So random state is to shuffle the data. For here 70% of data will be for training, right? So for that on your actual data, it will make a shuffle. So in my case, I'm giving a random state as 12. So 12 times it will shuffle and on the 12th time, whatever the shuffle data you are getting, it will take those data. So I'm just running it. So now data got splitted like x train, x test, y train, y test and all. So after this, what I'm going to do is I want to initialize. So for this also, I will write a command. Give me a minute. like trend test put I'm giving, and for this initializing logistic regression. So here I'm going to initialize this logistic regression. So what I'm going to do is, wait, I will scroll up. So here we have imported it. Here we have imported it. So if you want to use this logistic regression, we have to create a variable and we have to pass this. So that is called initialization. So in my case, what I'm going to do is I'm just giving log underscore reg. I'm giving a short form. Then after that, what I'm going to do is I'm going to type the logistic regression. Then open and close the parenthesis and just to execute this. So this algorithm is now this algorithm is loaded inside this log underscore reg. Yeah. Now this algorithm is loaded inside this log underscore reg. So after this, what you can do here, you have already splitted the data, right? So you can pass the training data for training purpose. Then after that, you can pass the testing data for testing purpose. Then you can evaluate. See, if you want to fit the data, which means if you want to train the data, means what you can do is log underscore reg of reg dot. Here you have a function called fit. Here you have a function called fit. Sorry. Just to use this fit. Inside fit, what we have to pass is we have to pass x train as well as y train. So I am passing x train comma y train I am passing. Then I am just executing it. So now my model got trained. See guys, within these two lines, which means you might fear of the algorithms, right? So previously I have showed you some formulas and all. So you no need to memorize or mug up those formulas. You have to understand the concept and how it is working. When it comes to machine learning algorithm, within these two lines, you will build the model. But this is not the actual thing. As an ML engineer, this is not the actual thing. The actual thing is like pre-processing before what and all we are doing. In our case, we are not having null values. So we are skipping those techniques and all. But in your case, if you have null values, means you have to work on those null values. So here my model is got trained. So what I'm going to do is like training model, I'm going to command it. So I'm just giving like a training model. Then after training, what we have to do, we have to test the model, right? So I'm giving test model. So here what I'm going to do is like I'm going to create a variable called pred. I'm going to create a variable called pred, and inside pred what I'm going to pass is I'm just calling this. So instead of typing, I'm just copying it and pasting it here. So dot, you have a function called predict. You have a function called predict. So predict of like x underscore test. Which means, see here guys, here we are passing only x test value. We are not passing y test. Why? Because y test is our actual value. For evaluation, what we can do is we can compare with the spread with the y test. So for comparison and all, what we can do, like from okay, we have to import the package. So from sklearn, from sklearn dot matrices, import confusion matrix. So in our case, we are going to deal with two different evaluation, like confusion matrix and classification report. So I'm just executing it. So here, what I'm going to do is I'm just calling this confusion matrix. So instead of writing, I'm going to paste it. So confusion matrix of. So here, what the value you can give is you can give the actual value, then you can give the predicted value. So in our case, what is the actual value? Y underscore test, right? So this is the actual value. Then what is our predicted value? PRED. Why? Because here we have used the, which means like whatever we are getting, we have saved inside the spread variable. I'm just running it. See here, you could find a, 1 second guys. Okay, guys. See, in our case, we are not getting a better accuracy. We are getting 60% of accuracy. So you can tune this model also. So currently, we are not considering on tuning the model. So see here, these are the diagonal values. So in our case, what our model is getting is on like whenever the value is 0. So whenever the person is not buying the product, so for that it is giving the correct output. For that it is giving the correct output. 73 observations were there. So for the 73 observation, it is predicting correct. So whenever the like a customer, whenever they are buying, so on the time our model is not predicting. So here at the overall at the average of this model is like F1 score is like 61%. You are getting accuracy. So see, as of now, this is not a good accuracy. If you want to get a good accuracy, means then this algorithms might not work well. You can perform some different techniques on this data, and you can transform this data, which means like you can scale this data and you can check. So you might get a better accuracy. Like that, you have to tune the model. So as of now, tuning is not possible. Why? Because within another half an hour, we have to cover the unsupervised learning as well as the theoretical as well as the practical session also. So this is the actual model training, testing, and these two are the evaluation. So just giving a title like evaluation I'm making. So these two are the evaluation of this model. So I will share this notebook at the end of the session. I will share this notebook on Telegram. Now we will go to the unsupervised learning. So now, can I get a quick confirmation on this chat that my unsupervised learning is visible to everyone, right? Yeah, okay. So see guys, previously we have seen the supervised learning. On supervised regression, we have seen linear regression. On classification, we have seen logistic regression. But then why this unsupervised learning? Why we have to use this? You might have this doubt. So I am giving some simple overview. See, whenever you are having a dependent variable as well as an independent variable, you can follow supervised learning. You can follow supervised learning. Whenever you are having only independent variable, you are not having a dependent, which means you are not having any output. You are not having any output. You are having just a data. If you have that input of data, means you have to follow unsupervised learning. So you might have doubt that how without output what we will do, like you might have doubt. So we have a k-means clustering algorithms. I will explain the actual working of the k-means algorithms and all. So when it comes to real time, each and every time we can't expect the output values. For example, if you are doing some project with some like Instagram. Based on the Instagram data, you are doing some which means you are doing some machine learning concepts means. So on that and all, the data might be different, right? So you can't get an actual output. You can't predict the actual thing. So from that, what you can do, whatever data you are having, with the data, you have to do something, right? You have to find the pattern. You have to find the insights in the data. So for that purpose, we are using unsupervised learning, and this unsupervised learning is mostly related to the deep learning concepts, which means like artificial intelligence concept. So here on unsupervised learning, we will learn about the K means clustering. So before going into this, I will give an example for this unsupervised learning. So for supervised learning and all, I have given like for regression, like predicting salary, and for classification, like true or no, so true or false type of things, and discrete types of things like that I have given. Where this unsupervised learning approach is used. For example, nowadays everyone are using the Rapido application, right? Nowadays on your mobile, everyone are having a Rapido application. So on that Rapido application, initially what you will do from your mobile, you will just click on that Rapido. From your mobile, you will just click on the Rapido. After clicking on Rapido, it will go to the Rapido application. In that, directly you won't give the location. Directly you won't give location. Before giving any input itself, it will show your current location will be marked as a blue color dot. Then around you, you could find some vehicles, right? Around you, you could find some vehicles, right? Can I get a quick confirmation on this Q&A? Yeah, on Q&A, unsupervised learning doesn't have dependent values. Yeah, we are not having a dependent values. Yeah, that's what, guys. If you try to open your Rapido application means, from that, without giving any input, automatically you, with the help of GPS, your current location is captured, and around you, you could find some bikes, right? Am I true? Am I correct or wrong? Yeah, guys, kindly give your answers on this Q&A. Am I right or wrong? Yeah. So how it is happening? How it is happening without giving any input? How something is happening? How the based on your current location, how the vehicles are available? There they are using this unsupervised learning approach. There they are using this clustering approach. They are using this clustering approach. 1 minute, guys. So let's understand what is K means clustering. So K means clustering is a popular algorithm in unsupervised learning. Uh, it is basically which is used on the clustering type of problem statements. So clustering, in a simple words or in a layman's view, clustering is nothing but an like a grouping. For example, on your classes or which means when you're studying on the college, you know, you will have some groups, right? Like your some this friend set will be your this group, like that. Some different groups will be there, right? I'm not talking about WhatsApp group. In a personal way, you might connected with your some of your friends, so you will have some group, and different friends, they might connected with their different friends, so there will be some different groups. That groups is called a cluster here. That groups is called cluster here. So see, guys, this is the actual data. Think this is the actual data. If you plot the data, whatever you are having, if you plot it, means it will be like this. It will be like this. So here and all, actually you are not having any output. If you have output, means you can perform linear regression or classification type of problem, right? So here you are not having any output. You have to find the output. You have to find the output. After finding the output, you can perform classification models. So here, after k-means clustering, it will be in the form of this thing. See, assume this is your entire class. This is your entire class, which means you and your friends are data. This plus or nothing but like you, your friend are available on, in your class. So after that, this particular like red color, then blue color, green color is there, right? So these are the three different clusters. So which means in your class you have divided into three different groups. So these sort of persons, like we can assume like this is a sports, then this is like an entertainment, and this is like a freak, like that we can categorize it. So whenever a sport person, which means whenever a person who is more interested on sport means he will whenever he come to this class means he will automatically lies to this category. Whenever an enthusiast person comes means he will automatically lies into this category. Like that, here we are grouping it. This process of grouping is called a clustering. Now let us understand how this grouping and all happening. How this grouping and all happening. Okay, wait. See guys, this is the actual step of k-means clustering. So on a previous slide, I have shown you that you could find like three clusters, right? Three different colors, right? So how it is giving like we have three colors. So while building the algorithms itself, we are making the model, which means we are making the machine to group that entire data into three different clusters. If I make it four means there you could find four different clusters. If I make it five means you could find five different clusters. So how we are picking that point? That is the important point. That point is called k, which means like k equal to 3. On previous image, we have used k equal to 3. So how we can calculate it? So these are the steps. So see, first we are choosing these are the steps for working of k means, working of algorithm. After this, I will show that elbow method. On elbow method, you could understand how we are actually doing it. See, on this first step, what we are having is we have to choose the number of k. We have to choose the number of k, which means like k equal to 2, 3, like that we have to choose. After that, what it does is the k point automatically takes the centroid point. So see, on back end, how this k-means clustering algorithm works is it works with the help of centroid algorithm. It works with the help of centroid algorithms. So automatically it will take some random points towards the data set, and it will try to find the closest point. It will try to find the closest point and it will make a group till it find a better centroid point. The computation will be goes on till it find a better point. The computation will be goes on. After that, it will be finalized. Then the model will be ready. So I will show some graphical view so that you can understand it in a better way. So see guys, this is the like actual data. This is the actual data. This plus symbols are the actual data. So here you have to perform some clustering. So what you are doing is they are making as a two. So this finding this value, I will come this thing later on. As of now, just understand the working of it. So here I myself I am giving a value as two. So after that, what happening is two data points, which means two random centroids are selected on this data. Two random centroids are selected. Then this line here, you could find some dotted lines, right? How this line is creating is from these 2 points, it will sum up the distance and it will divided by two. So if it happens, means what you will get? You will get the this distance will be equal to this distance. The distance from blue and this green line will be equal to distance from green and red line. So after that, whatever points available here, these points belongs to this blue point. See, these points belong to this blue and these points belong to this red. After that, what it will happen? This point will be moving here and this point will be moving here. Why? Because it has to find the correct centroid point, right? It has to find the correct centroid point. So it will be moving. This moving and all, it will happen on the back end. So don't worry about it. So automatically it will be moving. Then this is the new point. This is the new point. After that, it will find a better distance for these two. Then it will create a line like this. Then after creating a line, the points will be again segregated. After that, again it will be moves on like that continuously. After see, when it is moving from here to like a different location, this red color point belongs to this blue. So this red will be automatically joins to this blue point, and these blue points will be automatically joined to this red point. So this is what happening on k-means clustering. So see, after n number of, see, this is an much more computation thing. It will be goes on backend, tries to find, it will go to different random centroid points, and it will find the best point. See, at last, this is the best point. It is considering this as the best point. So top side, whatever region we are getting, it is clustering into blue color, and bottom side, whatever this is the region, whatever points we are getting, it is considered to like red color. So on further, if you add any data, which means if you add any data, wherever the data places, which means if the data places here means automatically it will be belonging to red color. If the data places here means automatically it will be belonging to blue color. So for example, the same example we can take Rapido. So if you are, for example, in Hyderabad, if you are in Hapsiguda region means, on Hapsiguda region, if you are opening the Rapido means, the locations, which means the Rapido vehicle which is available on Hapsiguda will be available to you on your mobile. If you are opening it in like Chengichella means, on Chengichella, if you open that means, on that region, what are the vehicles available, it will showcase. So what it is doing, it is clustering. It is clustering based on that region. Think this is one region, this is one region. So if the person is here and if he is opening his application means, what are the available vehicles available, it will showcase on your mobile. If the person is on this location and if he is opening the application means, whatever the vehicles available on this region, it is showcasing to you. I hope everyone understood this k-means clustering, right?
I saw some guys asking the steps of K-mean clustering.
Yeah, sure, Susan. Yeah, guys, these are the actual steps of k-means clustering. 1 minute. Yeah, these are the actual steps. First, what we are doing is we have to classify that. If you want just to take the screenshot of it. So if you want to do this k-means algorithm, so first we have to give the numbers, which means like k numbers, nothing but a cluster numbers. After that, automatically on backend, the system will take a random k point, which is nothing but a centroid point for the values, whatever you have given. So then it will tries to find the, it will segregate those 2 points with the help of a line. It will segregate with equal distance. Then after that, each and every time the points will be shifting, which means the centroid points will be shifting. And at last, see, previously it was like this, but at last, see, at last, this is the clustering point. This is the best point. So this region I have explained, right? If the person belonging to this region means automatically he will be on blue color. If the person belongs to red color means automatically he will be on red color. Yeah, 1 second. So on step 1 itself, what we have done, randomly we are giving k value like 1, 2, 3, 4. For our case, we have given 2, 3 and all, right? So what we are doing, randomly we are giving. So the problem for randomly giving this value, let us understand the problem. If we just give random values means what are the problem we are facing? See here, by seeing this data itself, we can understand this is one cluster, this is one cluster, and this is one cluster. We can easily understand it, right? If we are giving a 1 minute, guys. So if we are giving a correct cluster means it is well and good. It is well and good. But if you are not knowing and if you are giving a cluster as 2 means something might happen, right? Like this might be 1 and this entire thing might be 2. This is one case. And the other case we are giving cluster equal to 3. But what my machine can take is it will take this entire thing as 1. And here like here 1 point and here 1 point. Like that it can take. Let me show the next slide. 1 minute. Yeah. See, it can take in this type also. So on the time, my model is not performing in a good way. Why? Because by seeing this itself, we can easily understand this is one cluster, this is one cluster, this is one cluster. If we have 100 data means we can do it manually itself. But if we have millions and millions of data means manual is not possible, right? Manual is not possible, right? So on that case, what I'm doing is I'm going to do an approach called elbow method. So when it comes to on practical so I'm going to do a elbow method. So on practical session, which means the next 5 minutes you will start the practical thing. So on practical, I will explain you how to do the elbow method or not. So before going to elbow method, just to understand this term, WCSS, it is nothing but within cluster sum of square. So this is the formula. This is the formula for calculating the correct clusters. So this is the formula for calculating correct clusters. So distance of the data point, then cluster one whole square plus the summation of distance of data points, then cluster two data points and cluster three, like that it goes on. How many clusters you are giving, like that it goes on. This is the actual formula. So on practical implementation, I will explain it in a deeper way. Yeah, see guys, if I plot after that elbow method, if I plot the graph, the graph will be in this form of like this. It you could see why we have named it as an elbow. By seeing the line itself, you can find the elbow, right? By seeing this line itself, you can understand it is in a form of elbow. If you just fold your hands and if you check means, you can easily understand your elbow shape and this line shape both are similar. So here on elbow, you have to take the elbow joint. So here in this case, what is the actual joint? 3 is the actual joint, right? So 3 is the actual joint, right? So optimal number of clusters is 3. In this case, optimal number of clusters 3. So after this, after finding with the help of elbow method, after finding the actual k value, then you can use k means. Then the whatever accuracy you are getting, it will be in a better form. Now let us go to the practical implementation. So see guys, in my case, I'm not going to create another new notebook and all. I'm going to run on this notebook itself. So what I'm going to do is I'm going to leave like 3 to 4 cells. I'm going to leave and I'm going to work on it. So before working on, we have to load the data set, right? I have already shared the drive link with you guys. So if you find that, if you go to the drive link, you could find the segmentation data.csv. So we are going to use that segmentation data.csv. So what I'm going to do is like I'm going to upload it. So if you want to upload it to this interface means, what we can do is here you could find the first icon you could find, like upload a file icon you could find. Just to click on that, it will go to my computer. Then from that, whatever the dataset, if you want to upload, you can click that and click on open. Automatically the dataset will be uploaded. So here I'm just giving the title like K means I'm just giving a title. So then after this, what I'm going to do is I want to read the data set, right? So I'm just typing reading the data set. So this is reading the data set. So on reading the data set, what I'm doing, I'm just creating a variable called data. Why? Because for previous model, I have used the word df, right? Data frame I have used. So for this, I'm giving the name as data. How I can read with the help of pandas, right? pd dot read underscore of csv. Then I want to copy the path. So I'm copying this path. Then in single quotes or double quotes, I'm pasting it. Then I'm executing. Now the data set is loaded inside this data. Now I have to visualize the top 5 values. So what I can do, data.head can be used, right? So see, this is the actual thing. What you could find, ID you could find, then sex you could find, then marital status you could find, age you could find, education you could find, income you could find, like occupation you could find, then settlement size you could find. Here we are not having any like target variable. Here we are not having any target variable. From this data, we have to make a target variable. We have to make a target variable. Then if you want, you can perform with classification types of problems. So in my case, what I'm going to do is I want to find the data types. So what I am going to do, data.info I'm using. You can find with the help of type also you can find, type keyword also you can find. In my case, I'm using data.info. So here what I could get is like everything is int. So I no need to do future, which means like future mapping or label encoding, encoding techniques and all I no need to use. Now I want to check for the null values, right? So what I'm doing, like, okay, before checking the null values, I want to check how many rows and columns I'm having. So for that, what I can do, I can do data.shape, right? So with the help of data.shape, I'm getting like 2000 rows were there and 8 columns were there. I'm just commenting it. So finding shape like that I'm making here. So after that, what I'm going to do is I want to find the null values, whether my data set, which means the whatever data I'm having, they have null values or not. So I'm just doing like finding null values I'm giving. So here what I'm doing is data dot is null, then dot sum. So see here in this data set also we are not having any null values. So we can skip the steps of handling null values. We can skip that and we can go for the further things. So here in this case, I want to find the descriptive statistics for this data. So what I can do, like I'm just giving the name as descriptive stats like that I have given, then like data dot descriptive. I'm using data dot descriptive function. Sorry, data dot describe, sorry. I'm using data.describe function so that in my case everything is int, right? So I no need to use include equal to all. So for all the columns, I'm getting the count, mean value, then standard deviation, then minimum value, maximum value, 25th quartile, which means quartile 1, 2, 3, 25th percentile, 50th percentile, 75th percentile, everything I could see. After that, what I have to do is I'm I'm finding the correlation of this data. So how I can find this correlation? I'm just creating a variable called core. So inside that, what I'm going to do is I'm just going to do data dot core. Let me keep it one R itself. So data dot core, and then just copying it. So see guys, this is the correlation. See, whenever on correlation, diagonally on diagonal values you will get one only. On diagonal values you will get one only. Other than this, here you could find the correlations and all. And see, whenever you are doing a machine learning approach, means if the correlation is greater than 0. Like 90% is correlated, means you no need to use the two columns. From the two columns, you can use either any one. So here and now, in our case, we are not having that case of like that case of things. So by seeing this, it is not somewhat perfect, right? So if it is an like graphical representation, means it will be more helpful for that. So for making a graphical representation, what I'm going to do is I'm going to import the Seaborn package. So import Seaborn as SNS I'm doing, then I'm running it. Then on Seaborn, we have a wonderful function called a heat map. So in this heat map, what I'm going to do is I'm just going to give a core, which means nothing but our correlation. See here, guys, these values, it is converted into a colors. So it is more attractive, right? Here you could find the range. Here you could find the range. If it is completely like white color and this color, means you can assume that it is a highly correlated thing. It is a highly correlated thing. So here, if you want to mention those values in inside this box, means what you can use is you can use are not equal to true. It is a parameter. Are not is nothing but a parameter. So use are not equal to true and execute it. So inside each and every box, you could find the correlated values. Inside every box, you could find correlated values. In our case, we are not having 90% correlated, 85% correlated or not. So we no need to remove anything. Just we can drop this. Just we can drop this ID. Why? Because ID is not required for each and every customer. They will have a different, which means unique ID. So ID is not required. So we will remove this ID. Then we will go for further on. So on previous code itself, we have learned how to remove ID and all. So what I told drop function, right? With the help of drop function, we can remove it. So what I'm going to do is like dropping unwanted. Okay, drop unwanted column. Then here what I'm going to do is like data.drop. I'm passing the column. Columns equal to ID. Then like I make it as a comma. Then in place equal to true. Why I'm using in place? I want to update for each and for all things, right? So I am making in place equal to true. Now if I just type data means instead of data you can type data head also. So if you just type means the first ID, which means the first column ID is removed. Now this data is ready for our further procedure, which means for the process. So see here guys, this clustering algorithms on PPT itself I have shown it. So clustering algorithms, it is highly sensitive to the outliers, right? It is highly sensitive to the outliers. So see in our data we are having, if we are plotting something means we are having values like 0, 0, 67, 2, 1, 2, and all. So like this 0, 1, 2, these things lies between the which means a small region. But this 1 lakh and all, it will lies between like it looks, if you plot this means it looks odd, right? If we plot this means it will looks odd, right? So what we can do is we can do the like pre-processing techniques, which means we can transform this value, scale the value. So in our case we are using min-max scalar. So this min-max scalar is nothing but an normalization. So for normalization also we have some formulas and all. So you no need to like memorize those formulas. Why? Because same on SQL on itself we are having that package. Just we have to import it and you have to use it. So I'm importing. What I'm going to do is from SQL on pre-processing. Import min-max scalar. Yeah. See from SQL node pre-processing, I'm importing min-max scalar. So what it is happening is the min-max scalar, it will be automatically converting these values into zeros and ones, which means values lies between 0 to 1. If it is 1 lakh means this values will lies between 0 to 1. That's it. So here in my case, what I see after importing, what we have to do, we have to pass this, or we have to initialize this to a new variable, right? So I am initializing it. So I'm just giving a title as initialization and like I'm giving like num. So num equal to min-max scalar. Then I'm opening close the parenthesis. So now I'm executing. So this particular module is saved under num. So now whatever we want to do, we can do with num. So here in my case, what I'm doing is I'm making like data equal to. So here what I'm going to do is like num dot fit transform. So fit transform function is there. So you might have doubt that previously we have used fit. Here why we are using fit transform. So previous algorithms we are training the model. So for training you have to use fit. When you want to transform, which means you have to change from one value to another value, means you have to use fit transform method. So on fit transform, what I'm doing is just I'm passing the data. So here in this case, we are not going to train test with the data and all. Why? Because we are just performing the clustering, right? We are just finding the target variable. After finding the target variable, you can move with the classification types of problems. So I'm just running it. See, now I'm just typing data. See the output. Automatically the data will be converted into numpy arrays, NP arrays. Nothing but numpy arrays. Then previously it was in data frame. Now it is in the form of arrays. So here what we can do is, okay guys, give me a minute guys, I will execute the count first. So here instead of data, let me give a new name like data new, like that I'm giving, and I'm executing it. Same thing. So the same thing I'm giving here and I'm executing it. So this is the actual value. This is the actual value, which means, sorry, this is the transformed value, but the actual value is a data frame. Now what we have to do is we have to change this n-dimensional array into this data frame. So how we can do? How we can do? See, I'm giving data underscore. Let's change it here itself. Data underscore new equal to, here what I'm doing is with the help of pandas we can create a data frame. So pd dot data frame of here what I can give is I can give the data underscore new itself, data underscore new. So now this numpy array, which means like this numpy n-dimensional arrays will be converted into a data frame without any column name. So if you want to give the column name, means what you can give is we have a parameter called columns. So just use the parameters, then equal to, for data we have column, right? So see data dot colu, we just execute it, means here you could find the entire column names. Here you could find entire column names. So just to pass it here. After that, what I'm going to do is dot head. I'm using head function to visualize the first 5 values. So see here, previously we have 1 lakh values and all. Now those values are transformed. Those values are transformed with the help of normalization. It got transformed. Now if you are creating an algorithm, or if you are trying to make a plot, means all the values will be on same range. So our model might get a good performance. So from here, what we are going to do is we are going to implement the k-means algorithm. So for k-means algorithms also, you don't need to write codes and all. From SQL itself, with the help of clustering, you can get the actual algorithms. So here, what I'm doing is from sklearn.cluster import k-means. So what I'm doing is from sklearn.cluster import k-means, I'm writing it and I'm running it. So this k-means algorithms, which is available in this cluster, now it's get imported. Now after importing, what we have to do, we have to initialize to a variable and we have to build the model, right? But on PPT, what I have to, before building the model, we have to find the k value. So how we can find? With the help of elbow method. Now let us understand how we have to write the code for elbow method. So WCSS equal to, like, open and close the parenthesis. So here what I'm going to do is I'm going to make a iterative. So which means like for I in a range of like 1 to 20. So 1 to 20 means we have to define with 21, right? Why? Because the last value it won't take. So for I in range of 1 to 20, like k means equal to, okay, first I will write the code, then I will explain you that what I'm doing. Here like n underscore clusters, and then comma like random state equal to 0. Wait guys, first I will write the code, then I will explain. Yeah, see here, now here what I have done is, I'm going to make an iterative for the range 1 to 20. Why? Because k values randomly we can take 1, or randomly we can take 2 or 3, right? We have to find the perfect k value. So in my case, I'm trying to check the perfect value from 1 to 20. So I'm creating a variable and I'm initializing the k means here. Here this n cluster. N cluster is nothing but our k value. I'm giving us I. So if we are passing this inside this for loop, means what it does is all the values will be saved here. So how we can save it? Before that we have to fit it, right? So for example, sorry, k means dot fit. We have to pass the value. So what I'm doing is k means dot fit data underscore new. Nothing but this is our data. So I'm just copying it and I'm just pasting it. So after that, on k means itself, we are having a like inertia function. So what that inertia does is it will automatically give the cluster values. You no need to check for the cluster values. Automatically it will give the cluster values. WCSS dot append. So what here I'm doing is whatever value I'm getting, that value should be saved inside. For this 20 values here, some computation is going on. Then I am getting an output. That output value should be saved in this WCSS append of k means dot inertia. So k means dot inertia. So I am just going to run this. It will takes like 20 to 30 seconds it will take. So kindly wait for 20 seconds. So see guys, now it got executed. Now it got executed. Now we want to see the elbow plot, right? Why? Because with that elbow plot only we could understand, like we can take this k value or that k value, like that we can understand. So how we can do that elbow plot? So in this case, I'm going to import matplotlib. So now I have executed this matplotlib. So after that, what I'm going to do is I want to make a plot. I want to make a plot. So how I can make that plt dot pyplot. Sorry, pyplot dot plot of. In this plot, what I can give is the x value. First one is x value. The second one is y value. So on x value, I am giving like a range of 1 to 21, which means 20 values will be available. After that, on y values, what I'm giving is I'm giving WCSS. I'm giving WCSS. After that, plt dot pyplot dot show. So I'm just running it. So see here, you could find some elbow point. Here you could find the elbow drawing, but you are not knowing that what is this value, and all. You are not able to understand it, right? So for that, what I'm going to do is I'm going to give titles for these things. So first of all, like plt.pyplot, I'm just copying it each and every time instead of typing it, I'm just copying it. Dot. So here I'm having a function called the title. So inside this title, so inside this title, what I'm going to do is I'm going to give a title like elbow method. Guys, now the next 3 lines, whatever I'm going to do, that is not the mandatory thing, but to visualize this graph in a better way, we can perform that. So after that, what I'm going to do is like x label. So we are giving a name for x-axis as well as y-axis. So on x label, I am going to give the name like number of clusters. So I'm giving a short form like CLUs like that I'm giving. Then I'm copying it, then I'm pasting it here. Instead of X, I'm replacing it with Y. So here what I'm going to give is previously whatever we have saved on WCSS. I'm going to give that WCSS. Then I'm executing it. Now see the graph, we have a title, then we have a name for this x-axis and we have a name for this y-axis. Then we are having some graph, but we are not able to get the actual points. So to highlight those points, what we can do? What I'm going to do is, I'm going to write a marker. So marker equal to like 0 I'm giving. Then I'm going to give a size for this marker also. So marker size is as 5 I'm going to give. See, now I'm executing it. See here, on each and wherever the point is available, that point is replaced with this 0, which means like a point it is replacing. That point size we are making it as a 5. If I make it 10 means it will be too big. See, I'm making 10 and I'm running it. It is too big. But in our case, that 5 is decent, right? It looks neat, right? So here, check guys, this is the elbow diagram. From this, you have to take the correct elbow point. Now on Q&A, I'm seeing. So you have to, from this till, what is the correct elbow point? What is the correct elbow joint? Guys, give the number. If it is wrong, not a problem. From this points, which means this is the values. From this values, which is the correct elbow joint? Okay, like 7. Okay, any other answers? Like in between 5 to 7.5. Yeah, 6. 6 is the Agarwal has given. So 6 is the actual answer. So see guys, this is the actual elbow point. From here, if you fold your elbow means like some straight it will be there. Then after a point, you could find the actual straight line. So here in this case, 6, like 5, then 6, then 7, then 7.5. So this thing lies under the 6. 6 is the actual elbow point. Now we are going to build the k-means model with the help of k value as 6. We have found the k value. So like k means km, like that I'm initializing the variable like km. Then here what I can do is I want to write the name, right, which means algorithm, whatever we have imported previously. Here whatever we have imported, I'm giving k means. Then I'm opening and closing the bracket. Here you could find the parameters. So as default, the parameters will be 8. As default, the parameters will be 8. So in this case, what you have to do is n underscore cluster. With the help of elbow method, we found that cluster 6 is the best one, like that we found. So I have made cluster 6. Then after that, what I'm making is I'm making random state equal to 0. Why? Because the data no need to shuffle the data. So I'm just giving random state equal to 0. I'm giving. Then I'm going to execute it. See, after that, what I'm going to do is like ypred I'm giving whatever name variable. See, this variable name and all your wish, whatever name you want you can give. So I'm giving the name for my comfortable. So on y came in, what I'm going to do is I'm going to fit the data. So previously we have initialized the model. After initialization we have to fit it, right? So for fitting, what I'm going to do is km dot, here we have a function called fit underscore predict. So where is fit underscore? Okay, wait. Fit underscore predict. We are having a function called fit underscore predict. Inside that, you have to pass the data name. So here, what is your data set name? Data underscore new, right? So I'm just copying it. I'm just pasting it here. Then I'm executing it. Now copy this. We want to visualize, right? So when I'm visualizing on first data, which means first we have some row, which means some input were there, right? That input comes under 2. Second input comes under a 4. This is the output value. This is the output value. So on Q&A, I could find that without a target variable, how it is possible. Like we one query I found. So see guys, this is the output value. After this, you can perform this logistic approach and all. You can split the data like X and Y. This Y is nothing but the classes. Now what we have get clusters. So we can keep the clusters as Y. Then with the help of X is nothing but our entire input data. After that, you can split this data, then logistic regression you can perform. So why unsupervised learning is helpful? This unsupervised learning is helpful to find the like target variable. Let's take again. Let's go to the Rapido itself. So on Rapido, whenever you are logging into the application, some vehicles are available. After that, you are giving some input, which means from this location to you have to move to this location. Like that, you are giving some location. After that, if you click on book means one a best vehicle is which means one like best rider is assigning, right? How it is assigning? After this, they might perform the classification types of things, and they might assign the uh, a best rider. So see here, I want to import. See if I just type data underscore new dot head I am visualizing. So see here, this is the data, but with this data we can't. It is not we can't do the logistic regression, right? So here what we can do, we can pass these values into here. How we can pass data of, like instead of clusters, I am giving just CLVS. I'm giving this name, a short form I am giving class. So inside this, what I am passing, y bread, whatever value I am getting, I am passing here. Then I am executing it. Oh, sorry, data underscore new. So I am passing and I am executing it. After that, I am going to give this and I am going to run it. So see here, now we got independent values as well as dependent values. Now from this output is in the form of discrete, right? So you can perform classification. That's it, guys. This is the now we have covered the supervised learning classification as well as unsupervised learning techniques. So and we have exceeded the time also till 8 o'clock only. We have time, so we have exceeded the time also. So on Q&A, let me try to answer your queries. So can you show the code for splitting the data? Yeah, after this session, I will just share the code on Telegram itself. So you can refer the code and you can work on it. Yeah, please scroll a little bit. Yeah, guys. Actually, I couldn't see this query. So I will share this entire, which means a notebook as well as a data set link. I will share on a Telegram group. So you can open this and you can work on it. So what is test used for? Yeah, see guys, for example, on your college, you are like training sessions is happening, which is nothing but your normal periods. After that, at the end, you are having some exams, right? So that some exams is called a testing. So evaluating whatever you have learned, we are evaluating it. That's it. So Argyros, you are having a doubt like on heat map, right? So on heat map is a function which is used to represent the correlations in the form of graphical view. So some color visualization will be there. So core is nothing but the correlation. Correlations are like same information from, which means two columns will be there. So how correlated? This column is how correlated to the other columns. For example, if you are having on a family, you are having two brothers means. So from the two brothers, you might have some relations you might have, and some things you might get differ. But when it comes to like twins means, identical twins means everything will be same, right? Yeah, guys, you are asking for Telegram link. Uh, Yeah, guys, on tomorrow session, the tomorrow's channel will share the Telegram link, guys. So a number of queries are coming. Building the project, we get the data. No, while building the project, whatever data you are getting, it is not pre-processed. After getting the data, you have to do the pre-processing techniques about. See, CORR is nothing but the finding correlation. So finding correlation between each, which means one variable to other variable, we are using CORR function. Yeah, in KN and also the same thing. We can see previously while initializing you have used logistic regression, right? Instead of logistic regression, you can use K nearest neighbors and you can do the classification types of problems. Yeah, you want to know the how to upload your data set on IBM, right? So on IBM, if you are going to the notebook means on right side top corner, you could find a Boolean symbol like 0100 like that one symbol will be there. So just to click on that symbol, then you can directly upload. It will ask you to, you could find an option called upload. So click on that upload and you can click that data set from your local system. Then just to click on OK, then automatically the data set will be uploaded. Yeah, most of the queries is like show the previous lines like that. I could find most of the queries. So those queries, as I said, I will share the data set as well as notebook on Telegram. So from that you can easily assess those things. So why we need to convert categorical data into numerical data? Yeah, see guys, when we are performing a machine learning approach, which means when we are doing some machine learning algorithms, we are creating a model with the help of machine learning algorithms. On that time, the algorithms will accept only numerical data. Algorithm won't accept categorical data. So you have to convert the categorical data into numerical data. Otherwise, you will get an error. Yeah, yesterday's recording you didn't get. Yeah, so kindly give us some time. So we will provide the recordings and all with you. So kindly give us some time. Yeah, actually core is a predefined function. Inside the core, it is a predefined function. Just you can use that, then you will get the value. The formula is built inside the core function. So you can just use, instead of writing a formula in code and all, so just you can use it. Yeah, categorical data means string, object, those sort of things. Object is nothing but a combination of strings and numerical. So can you use VS Code? Yeah, you can use VS Code. See, on upcoming sessions for these things, deployment and all, most probably will use Spider and PyCharm and all. So in your case, you can use VS Code. Any IDE is best. Yeah, okay, guys. I hope today's session will be an informative session and everyone enjoy the session. I think so. Why did we use data frame? What data underscore? Yeah, you're asking the query that like why we are using pd.data frame. What data underscore new? Why we are using means if you are transforming the data, then the data frame is converted into one NumPy multi-dimensional array. We have to convert that multi-dimensional array into one data frame, right? So for conversion, we are using pd.data frame. Yeah, guys, we will try to provide the recording on time base. So most probably you will get within tomorrow. Within tomorrow evening 6 o'clock, you will get those recordings. Yeah, thank you, guys. Thank you, guys. Thank you for your cooperation. So thank you, guys. So I'm not able to understand how would this beneficial given data for us. Can you elaborate? I'm not able to understand. Yeah, thank you everyone. See, you are asking the doubt like why we are using WCSS, right? On slide itself, I have shown. See, can you see it like within cluster sum of square? The actual definition for WCSS is within cluster sum of square. So here, what we are finding is we are finding the best clusters. So we are finding the best clusters, which means the position of clusters. This if this point should be positioned here, the another point should be positioned there. Like that, we are finding it. So for that purpose, we are using WCSS. Yeah, okay, guys. Thank you, guys. Thank you, guys. Thank you for your cooperation with me for the 2 hours. Thank you.